In this video, I'd like to tell you about the two laws of light, and it might extend into a couple more videos after this. So the model of light that we have going at the minute are two of them. The first one is light's a photon, and when it's a photon, you can sort of draw light as streaming around like small little balls of light, and they can be sort of zipping around at the speed of light in any old direction that they are aimed. And the other model, of course, is that light is a wave. And in the wave model, light sort of looks like this. And as we discussed, for waves, you have something called a wavelength, and sort of the up and downness, which is the frequency, and the amplitude of the wave, which is called A, which can be related to the power or the intensity of the wave. It turns out, though, that using these models in particular to discuss things, say in astronomy, is a tad bit complicated. The photon view is a very sophisticated view of what light is, and it's sort of where quantum mechanics comes from, and is a very sophisticated way of discussing what light is. And a wave is as well. There's a lot of really funny wave properties like interference that one would have to consider if you're really going to go down the wave model, but we're not going to worry about that either. We would just like to discuss some things that we see in astronomy. And so what we do then is we take both of these things, we say, okay, we know what light is, we know it can behave like a photon, we know it can behave like a wave, and photons and waves have all these nice properties, but let's just wrap them all up into one thing, which is going to be sort of a straight line like this, and let's just call it a light ray. We'll just call it a light ray then. And light rays, of course, travel in some direction. You can always put an arrowhead on a ray to indicate the direction of travel. And naturally, the speed of these rays here will be the 186,000 miles per second, or the 1 foot per nanosecond, or whatever speed you like to associate with light. That's how fast the ray travels. So we'll just keep light as a straight line. And it turns out that if we do this, there's all kinds of stuff in astronomy that we can discuss and discover and understand and all that sort of thing, not having to worry much about these models. But just keep in mind, though, that if you dug very deeply into what light would be then, if you put a magnifying glass right there and looked in there like, maybe 1,000,000 times or more, what would you see inside of this little magnification area right here? Well, depending on what you're looking for, you would either see photons streaming by, or you'd either see waves streaming by. So just keep that in mind. So the photons or the waves, whichever you like to think light is, would all be encapsulated into this one straight thing we're going to call a light ray, which is none other than this straight line arrow that we can draw that travels at the speed of light in the direction that we send it in. Okay, so with that then, there's two laws of light that we need to discuss here. One is called the law of reflection, and the second one is called the law of refraction. Law of refraction. So be careful with these. They both start with an R. They both have about the same number of letters in them. One is reflection, and the other is refraction. So what we'll focus on in this video is the law of reflection, because it's fairly straightforward, and we'll get on to refraction in the next video. So the law of reflection is pretty straightforward. So it just says this. Suppose you have a light ray coming in like this, maybe going in that direction, and there's something down here that it hits. Let's just say something like this. Just could be anything. And this thing that it hits here could be water, could be glass, could be concrete, could be a planet. It could just be anything you can think of. Suppose light comes in and hits it. This is very common, right? It's very unusual for light to just stream on and never encounter anything. So just suppose it comes in and hits something like water, glass, concrete, a planet, a moon, a rock, dirt, whatever. Just imagine it hits this. What is it going to do? Well, it's going to come in like this. Let me try to extend this line here like this, and it's going to hit the surface right here. There's going to be some interaction right here, and we're talking about the law of reflection at the moment. So what light's going to do, it's going to reflect off the surface like this. And the most particular thing about light, the way the law of reflection works, is the ingoing angle is always the same, is always equal as the outgoing angle. Let me try to describe that a bit more. So if you look at this drawing that we just put down here of light coming in, it sort of goes in like this, hits the surface right here, comes out. Sort of like boing, something like that. So what angle are we talking about? Well, it's very tempting to talk about this angle over here or this angle over here, but we don't do it that way when we're talking about light. We always draw a line, an imaginary line like this, which is perpendicular to the surface that light is hitting. So if this is the dotted line we're talking about, here's the surface it's hitting. Here's the perpendicular angle right in here. So these two are just locked perpendicular. And this line here is called the normal line. It's not a light ray. It's not part of a light ray. It's just a reference line that we're using to get these angles hammered out. And the angles that we're going to concern ourselves with that are equal for the law of reflection are namely this angle right here. Let's call this theta 1. And this angle right here, theta 2. Those are the two angles that are always equal. So theta 1 is the ingoing angle and theta 2 is the outgoing angle. For the law of reflection of light, theta 1 is always equal to theta 2. That's essentially the law of reflection. That's how light reflects when it encounters some surface. So this is your law of reflection. It's none other than that when a light ray comes in and encounters a surface, it's going to bounce off, and the angle that it bounces off always carries equal angles with respect to that normal line. So we'll pick this up and look at some examples in the next video.